So the topic here is rules of indices. The questions are taken from a foundation paper. Now, rules of indices can be on a higher paper as well as a foundation paper. It's just based on the level of difficulty. A question like these would be on a first half of a higher paper. If you increase the level of difficulty, it would be on the second half, but this is mostly taken from a foundation paper. In order to answer rules of indices question, what you need to know is a set of index laws. Okay, the laws of indices that we apply to answer these questions. There are a set of them, and you need to know them. You need to be able to identify this is a rules of indices question, and you need to know which rules to apply. Okay. The way you identify it, if I have, for example, here we have 3 to the power of 5 times 3 to the power of 4. So if I have an example of a number a to the power of m times a to the power of n, what we call these are the base. The base, whenever they are the same, we have a set of rules of indices that we can apply. Okay, so this is the same base. That means we have a set of rules. If you're multiplying two numbers that have the same base and have a set of powers m and n, what we can do with those is you can add the powers. Okay, when you multiply, you add the powers. That's your first rules of indices. The second rules of indices is when you have the same base and you are dividing two terms. This can be written like this or like this. As you can see from the example that we have, what we have here is actually a fraction, so it's written one over the other. When you're dividing, we subtract the powers. That should have said addition. We add the powers, and here we subtract the powers. Okay, so a question like this, for example, you are multiplying 3 to the power of 5 times 3 to the power of 4. We're going to add the powers here. So 3 to the power of 5 plus 4. And that's going to give us 3 to the power of 9. And the denominator, as you can see, what I did there is I dealt with the numerator first, the number of the top first. Then I'm looking at, so what do I do with the denominator now? So you're dividing. That means you subtract the powers. You minus 2 from 9. Okay, so it's 3 to the power of 7. That's your final answer. So you don't need to find what 3 to the power of 7 actually is unless the question says evaluate. If they say evaluate, you need to find the actual answer for this. But a higher power like 7, they will not ask you to find what 3 to the power of 7 is. They just want to know if you can apply these simple rules of, when you're multiplying, you add, when you're dividing, you subtract. So these are the rules of indices that we used here. In addition to this, I'll go through another two. The next one is when you have a to the power of m, and then you have a bracket around it, and then put a power of n. Okay, brackets means multiplication. Always remember, brackets means times. So brackets means times. Okay, so which means what we're going to do here is we're going to take these powers and times them. So a to the power of m times n. So that's the third rule of index law. And the last one I want to go through with this one before we answer these two, those are advanced sort of laws of indices that you need to know, is this law here. So if I have a to the power of minus 1 here. Okay, a to the power of minus 1. What we do for a to the power of minus 1, in order to get rid of the minus, we flip the fraction. So this, to be written as a fraction, you write it as over 1. So all you have to remember is we take the 1 to the top and we take the a to the bottom and we leave it like that. Okay, a to the minus 1 is 1 over a. So for example, 3 to the minus 1 would be 1 over 3. Okay, all you can remember is the minus the 1 disappears when you put it under the fraction. Okay, when you put it into a denominator, you put it 1 over and the minus disappears. Okay, it actually becomes a power of 1, but you can think of it as the minus disappears, so 1 over 3. So those are the basic set of rules we have there. And then these here, you need to remember this one. This is an examiner's favorite. If I have something to the power of 0, your instinct would tell you write it as 0, but something to the power of 0 is always 1. Okay, anything to the power of 0 is always 1. Okay, make sure you remember that. That's a standard question that they love to test you now and again. Okay. The y behind the anything to the power of 0 is 1 is basically what you're doing here is you're dividing 12 by the same number. Okay, you have 12 to the power of 1 over 12 to the power of 1. When you divide something by itself, the answer is always 1. But what we're doing actually here is 12 to the power of 1 minus 1. Remember the second rules of indices that we had there? 1 minus 1, that's 0. So 12 to the power of 0 is always 1, and that's why it's always 1. You do need to remember that one. That's a commonly asked question. Now this one, I would say it's a bit advanced rules of indices question. 3 to the power of minus 2. We looked at what happened when we have minus 1, but what happens when we have minus 2. So what we're going to do here is we're going to look at that one. Is 3 to the power of minus 2. What we do here is anything to the power of a minus expression, we bring that term down exactly how we did for minus 1, but always remember the power here stays on, just that it's positive. And the numerator, you keep it as 1. So take that down, change the sign, put a 1 on top. So here, take this down, change the sign, put the 1 on top. So the answer is 1 over 9. Okay. You can leave it as 3 squared, but if they tell you to evaluate, you write it as 1 over 9. Okay. Thank you for watching.